In this video, we will look at how we can find the tangent line of parametric equations. Now recall that if y can be expressed as a function of x, the first derivative, or dy dx, simply represents the gradient or slope of the tangent line to the curve at any point. Now, given a set of parametric equations, how do we find dy dx? For any set of parametric equations, x and y are usually defined in terms of a third variable, for example, t. If we have x of t, we can always find dx dt, and if we have y of t, we can always find dy dt. If we want to find out what is dy dx, using chain rule, we know that dy dx will be given by this expression over here. And this expression can be rewritten as dy dt over dx dt, or simply y prime of t over x prime of t. So this expression over here will give us dy dx of our parametric equation, provided that your dx dt is not equals to 0. Let's take a look at this example. Find the slope of the tangent line to the unit circle given by this set of parametric equations at the points where t equals to pi over 6, t equals to pi over 2, and t equals to 2 pi. So recall that the slope of the tangent line to this set of parametric equations is given by dy over dx is equals to dy over dt divided by dx over dt. So in order to find the slope, first we need to find what is dx dt. We are given that x is equals to cosine t. Therefore, dx dt is equals to minus sine t. We are given that y is equals to sine t. Therefore, dy dt is equals to cosine t. So the slope dy dx will be given by dy over dt divided by dx over dt, which is equals to cosine t over minus sine t, which can be simplified to minus cotangent t. So this is our expression for the slope of the tangent line. Now we are asked to find the value of the slope at 3 different points. So let's substitute the values in. When t is equals to pi over 6, dy over dx is equals to minus cotangent pi over 6, giving us a value of minus square root 3. When t is equals to pi over 2, dy over dx is given by minus cotangent pi over 2, which will give us a value of 0. When t is equals to 2 pi, this is a very special case. Notice that when t equals to 2 pi, sine of 2 pi will actually give us 0. Since sine t is equals to 0, which is in the denominator, your gradient or your slope dy dx will be undefined. Let us now take a look at the graphical interpretation of these slopes. We know that this set of parametric equations correspond to a circle centered at the origin with radius 1. Let us first find the coordinates at each of these values of t. When t is equals to pi over 6, we have the coordinates of square root 3 over 2 and half. So this point is as shown on the graph, and if we draw the tangent to this point, we will get a tangent line as shown. When t is equals to pi over 2, we will have this set of coordinates of 0 and 1. This point over here is represented by this point, and when we draw a tangent to this line, we have a horizontal line with gradient of 0. When t is equals to 2 pi, we have this set of coordinates of 1 and 0. When we plot this coordinate on the curve, corresponds to this point over here. When we draw a tangent line to this point, we have a vertical straight line, which also implies that the gradient of this line is undefined. Without eliminating the parameter, find dy dx for the following parametric equation at this particular point. Without eliminating the parameter means that we have to find dy dx in terms of t. So we need to find dy dx, but before we can find dy dx, we will need to find what is dx dt and dy dt. So if x is equals to t squared, dx dt will be given by 2t. If y is equals to t cubed, then dy dt will be given by 3t squared. Therefore, dy dx, which is actually dy dt divided by dx dt, will be given by the expression of 3t squared over 2t, and if we simplify this, we will get 3 over 2t. How do we find dy dx at this particular point? So we know that at the point 1, 1, okay, this means that x equals to 1 and y equals to 1. So x is equals to 1 and y is equals to 1. So x has the equation of t squared, which is equals to 1. And solving this, we will know that t is either 1 or minus 1. When y is equals to 1, we have the equation t cubed is equals to 1. Solving this equation, we have t is equals to 1. Therefore, to find the value of t to substitute into this expression, we would have to take t is equals to 1 to be consistent at the point 1, 1. So we will reject this value of minus 1 over here. So when t is equals to 1, the value of dy dx will simply be 3 over 2 times 1, which is simply 3 over 2.